All right, today we're tackling something pretty specific but really fascinating. It's a piece of professional hardware called the Thor Broadcast F-8SD-ET-TxRx transmission kit.
And we're framing our deep dive around a core challenge, really. If you work in field production, you know the logistical
Oh,
nightmare.
absolutely. How do you move huge amounts of HD video, plus control signals, plus networking,
Yeah.
all of it, over massive distances with, like, the smallest possible footprint?
Exactly. And that's the mission this kit is built to solve. The core claim is honestly pretty staggering. It can transport up to 8 full-rate HD-SDI video signals.
8 of them.
8 plus Ethernet plus a bunch of control links, all consolidated onto a single strand of fiber optic cable. It's basically infrastructure compression in a box.
And when you look at the specs, that consolidation is just, it's incredible. We should probably mention this kind of integrated solution is priced around $5,995. Comes with a 2-year warranty.
Right, and that investment is all about drastically cutting down on cable complexity.
Okay, so let's start with capacity. What are we actually talking about putting down this one fiber?
We're talking 8 full HD-SDI channels.
Yeah.
So each one of those is a separate 1.5 gigabit per second stream. It's also backwards compatible with SD-SDI, DVB, ASI signals.
So 8 high-def broadcast streams all at once. My first thought is, how? How do you jam 8 fire hoses of data through one tiny piece of glass and not get, a total mess? Crosstalk, latency.
Right.
What's the secret?
The secret is a technology called time division multiplexing. TDM.
TDM.
Right, think of it like a super efficient traffic cop for a single runway. Each video stream gets its own incredibly precise, totally isolated time slot to send its burst of data.
Ah, okay, so it's not physically mixing the signals, it's more like meticulous scheduling.
That's it, exactly. The system makes sure that each of the 8 channels, and this includes its embedded audio and all the other data, is fully isolated. The key phrase from the source material is that each stream operates as if it were the only signal on the fiber.
And that's vital for live video, where timing is just everything.
Everything.
That integrity is crucial, especially because we're not talking about short runs inside a studio here. The standard distance is 20 kilometers.
Which is already pretty significant, yeah. But then you have options to extend that.
For things like, I don't know, covering a marathon or a huge industrial site.
Precisely. You can get options that go up to 40, 60, 80, or even 100 kilometers. And it's built for the field. It's rated to operate from 0 to 70 degrees Celsius.
Okay, so it's not just about the video, right? That's the other big piece here. It's more than a video pipe. It's also handling networking at the same time.
Yes, 10100 Ethernet full duplex. And critically, it has these dual auxiliary ports. The O ports are what really turn it from a transmitter into a full-on control hub.
The documentation on those O ports gets pretty dense, listing all the standards. Let's break it down. What can you actually do with them?
They basically manage everything non-video a remote site needs. You've got analog audio going both ways. You have traditional command and control data links, like your RS-232, 422, 485, and even simple physical triggers, what they call contact closures.
So you can mix and match all that.
You can. Up to 4 separate options for each O interface.
This all sounds incredible, but it does make me think, if you're putting video, network, audio, control, everything onto one tiny piece of fiber, aren't you just creating one massive single point of failure?
That is the classic trade-off, right? But the reliability of modern fiber optics and the simplicity of having just one run often outweighs the risk. Plus, this thing really shows its broadcast purpose by including a dedicated return path RS-485 channel.
And what's that for, specifically?
That's what lets the director in the control truck remotely control the PTZ camera pan, tilt, zoom that's sitting 50 kilometers away at the other end. It's that bi-directional control.
So if we boil it all down for you, the listener, what we're looking at is a kit that solves one of the most frustrating problems in media production.
It just combines everything: high bandwidth, video, networking, audio, and that all-important bidirectional control into one single reliable optical link. It's not just faster, it fundamentally changes the labor and materials you need for a remote setup.
And here's the final thought, the real knowledge nugget for you to chew on: the power consumption. For this massive level of consolidation, for moving 8 HD feeds and all that control data, potentially 100 kilometers.
How much do you think?
It's less than 10 watts. Just think about that for a second. Think about the historical effort, the power, the copper cable required to move just one analog video signal 20 kilometers, let alone all of this. That level of efficiency is what really changes the game for designing any remote broadcast site.